Lesson number 4, Daily Summary. In this lesson, we learn how to use dimensional analysis to do unit conversions and to help us set up proportions to solve application problems. Today we'll do 2 demos and 2 activities. Gas costs $3.57 per gallon. You fill your car with 12 gallons of gas and then buy some items for $15.35 at the counter. How much money do you give to the clerk before you type anything into the calculator? Write down what you are going to type into the calculator. So pause the video here and see if you can fill in that blank space and then come back. Okay, so if you're back, hopefully you wrote $3.57 times 12 gallons plus the $15.35. So that calculation is typed out right here. And ultimately we get $58.19. The numbers above don't have any units on them. Anytime we create an equation, the units on the left-hand side of the equation must equal the units on the right-hand side of the equation. What are the units on the right-hand side of the equation above? Well, this 5819 is dollars. So that means the units on the left must also be dollars. The only way this equation is true is if you have the same unit on both sides, and the right is dollars, therefore the left must be dollars. Let's examine what happens to the units as we perform the calculations. Fill in the blanks below with the appropriate units. You'll be writing words in the blanks. Okay, let's skip the 357, but that 12 is $12. Sorry, that 12 is not at all $12. That 12 is 12 gallons. The 1535, that's dollars. And as we said, the 5819 is also dollars. The first unit is the tough one, the one we skipped. So 357, is it $353.57? Is that the unit? Well, that's part of it, but that unit is not complete. It's $3.57 per something. Per what? Per 1 gallon. And then we can cancel because in the first 2 terms that are multiplied here, gallons here and gallons here cross off. And so that means that the units for this entire thing here is dollars because the gallons just went away. And then the units for this is also dollars. And when you add dollars and dollars, you get dollars. So everything works out just fine. Anyway, the point here is to convince you that units on the left for any equation, units on the left must equal units on the right. That's going to help us with setting up some word problems and proportions that we'll see. Number 5. Now we change gears and talk about ratios. We'll see that the dimensional analysis techniques from above will help us correctly set up proportions. A ratio compares 2 numerical quantities through the operation of division. A ratio is often written as a quotient or fraction, such as A over B. A ratio can also be written as A to B and then A colon B, which is read the same way as this one is said. A colon B is pronounced A to B. Let's solve the following proportion. A proportion is an equation stating that 2 ratios are equal. So take a look at our proportion. It's right here. It says that 2 ratios are equal, 2 fractions are equal to each other. That's the definition of a proportion. It's 2 fractions equal. Our basic technique for solving proportions is to multiply both sides by both denominators. Both sides by both denominators. This is written out. I'm just going to write a tiny bit, just this first step here. We're going to multiply both sides by both denominators. So the denominators I see are 7 and 5. We're going to multiply the left-hand side by 7 and 5, the right-hand side by 7 and 5. I'm going to go ahead and throw parentheses around these. It's not necessary in this case, but I'll put it. And then we're going to cancel. On the left-hand side, what cancels? Well, there's a 7 on top and a 7 on the bottom, and they go away. And on the right-hand side, 5 on top, 5 on the bottom, and they go away. And so all that we're left with is 5 times x minus 1, still in parentheses, and then 3 times 7. And that problem is great because it has no fractions left in it. So we got rid of the fractions by multiplying both sides by both denominators. In the very first demo, we actually got rid of some fractions inside of an equation by multiplying both sides by the lowest common denominator. This is a similar technique, right? Multiply both sides by all of the denominators you see. It might not be the lowest common denominator, but it's the same idea. That will get rid of all the fractions. So solving this is ordinary. I'm just going to point instead of writing the rest of the solution. But we distribute the 5. So that gives you this 5x minus 5. The right-hand side is 21. Add the 5 to get 26. Then divide by 5 to get 26 over 5. That's our answer. Note, some students have learned how to solve proportions by cross-multiplying. If you know how to do this, you are welcome to cross-multiply to solve proportions in this class, but it's risky unless you really know your stuff. So my preferred technique, my recommendation is no cross-multiply, but rather multiply both sides by both denominators. Next page. The ratio of male students to female students at GCC is 2 to 3. If there are 2,000 students at GCC, set up and solve a proportion to find out how many are female. So let's first define a variable. If you read the problem very carefully, you will see that I am telling you exactly what I think the variable should represent. You are going to answer this question with the variable. So you can use X to represent the variable, but it is trying to answer how many students are female. So don't let X equal females, let X equal number of females. Always have to have a quantity word and a unit word. Don't forget that quantity word. Okay, so let's go ahead and, I'm not going to read all the text here, but I'll just sort of explain in my own words. Let's start filling in some stuff here. I'm going to put the word males here and females here. And I'm going to put them in that order, just because that's the order here. It says male students, and then the keyword here, 2 female students. So I'll be true to that order, which would mean male students in the numerator and female students in the denominator. But as soon as I made that choice on the left-hand side, I must make exactly the same choice on the right-hand side. Just like in the gas example, the units on the left must equal the units on the right. And I think it is crucially important to setting up word problems to writing these units in both sides. A lot of students tell me they struggle with word problems. Well, take my advice. Write the units on both sides. I promise you will struggle a little bit less with these kinds of word problems by writing the units. You're going to make fewer mistakes by writing those units in. It takes like 15 seconds to write the units in, maybe less. Write them in. Okay, so reading the first sentence again. The ratio of male to female is 2 to 3. So that gives us the left-hand fraction. Male is in the numerator, 2 female in the denominator. 3 right there, 2 to 3. The word 2 basically just means divide, but you got to be true to the order. 2 represents males, 3 represents females. Okay, next up, look at your variable definition. You let X equal the number of female students. That is going to be one of the 2 blanks, right? It's one of these 2 things. Which one represents the number of female students? Well, it's the one on the bottom. And it's really easy to know that because we spent 10 seconds writing the words male and female on the right-hand side. So X clearly goes on the bottom because we made a really good definition for X and we wrote our units in. Okay, last blank in this proportion is the numerator on the right-hand side. We need something to represent the number of males. There is one piece of info we haven't used yet here, and that is that there are 2,000 students total. It is wrong to put 2,000 in this numerator. It might be tempting because it's the only other number you have left. But the numerator has to represent number of male students, and 2,000 is the total number of students. So we need something up on the top that represents not the total, but rather just the male students at GCC. So for some of you, you're going to immediately know what expression you're going to put in here. It's going to have X in it, but for the rest of us, we'll just make up a number. Suppose that X equals 500. If there are 500 female students at GCC, then how many male students? That's what we're after. So I think everybody hopefully is thinking 1,500, but again, you did a calculation. Number of males equals. So what calculation did you do to get the answer of 1,500 males? Well, you did the 2,000 students total and you subtract off the 500 female students. That gives you the 1,500 male students left over. So this is the pick a random number trick that we talked about recently. So what's the expression in general? Well, it's not 2,000 minus 500, it's 2,000 minus the number that we just made up, right? It's 2,000 minus X. So that's what goes right up here, 2,000 minus X. 2,000 is the total, subtract off the X female students, you're left with an expression for the number of male students. Do not bother memorizing that, oh, I just need to take the big number in the problem and subtract X, and that's always what goes in the last blank in the proportion. That is not true. There are going to be problems where 2,000 is actually the right thing to put in that last blank, not 2,000 minus X, but just plain 2,000. And there are going to be other problems where the right thing to put in that blank is 2,000 plus X. So really, it could be any of 3 options up there. And you just have to carefully read the problem and follow your unit words. If you put those unit words in and carefully read the problem, you are going to have a very good chance at putting the right expression in that last blank. Okay, so we're left off there with a proportion. So what you're going to do is work on activities number 1 now. finish those activities as best you can, and then check out the next demo video. It's not going to be in this video, but it will be in the playlist. Check out the video for demo number 2 after you finish the activities.